Good afternoon students. Welcome back to online mathematics class. So in the last class we have started with the exercise 6.2 and we have solved up to the 5th question. So in today's class let us continue with the 6th question. It is find the intervals in which the following functions are strictly increasing or strictly decreasing. In this we have 5 sub questions. In that I have taken the first one. So this is going to be very important for 2 marks. Any one simple question will be given for 2 marks, where we have to find the intervals in which it is strictly increasing or strictly decreasing. So now the first sub question, it is x square plus 2x minus 5. So we will take this as f of x. It is f of x which is equals to x square plus 2x minus 5. Then now we will have to go for f dash of x. So here f dash of x which is equals to, what do we get? 2x plus 2. Then now to get the point we have to equate f dash of x with the 0. So now f dash of x is equals to 0. So what do we get? 2x plus 2 which is equals to 0. Then 2x which is equals to minus 2. Then x is equals to minus 1. What is the point here? It is x equal to minus 1. This x equal to minus 1 divides the number line into 2 disjoint intervals. Is that clear? So now, this point, so this is minus infinity, this is plus infinity, in between we have minus 1. So now the point x equal to minus 1 divides the number line into 2 disjoint intervals, and the intervals are minus infinity comma minus 1 open interval, and then again another interval, it is open interval minus 1 comma infinity. So we have to go for the table now. It is intervals, sign of f dash of x, and the nature of function. Here I will be taking the intervals, then sign of f dash of x, sign of f dash of x, and then nature of function. Nature of function. So let us take the 2 intervals. It is minus infinity comma minus 1, open interval, minus infinity comma minus 1. Now in between these two, so it is an open interval, we have to leave the end points, take in between value now. So minus 1, minus 2, minus 3, so on up to minus infinity. So here we can take minus 2, minus 3, minus 4, anything. So I will be taking minus 5. So here substitute minus 5 in f dash of x. See here, 2 into, in place of x I will be writing minus 5 plus 2. So 2 into minus 5, it is minus 10. Minus 10 plus 2, it will be minus 8, which is less than 0. So in this open interval, f dash of x is less than 0. It is less than 0. If it is less than 0, then the function has to be strictly decreasing. So the nature of function, it is strictly decreasing. And then we will go for the second interval now, that is minus 1 to infinity, minus 1 comma infinity. So now in this we can go for 0, 1, 2, 3 and all the positive numbers. So I will be taking 0 now. So here let me take 0 and substitute in f dash of x. See here, 2 into 0, it is 0, plus 2, it is 2, which is greater than 0. Now take another number. We can take 3 here, plus 3. 2 into 3, it is 6. 6 plus 2, it is 8. 8 is greater than 0. That means in this interval, f dash of x is going to be greater than 0. It is greater than 0. Hence, it is strictly increasing. So like this you will get any one question for 2 marks. in your annual exam. So this is all about the first sub question. So write down this and then we'll move on to the second sub question. Well, the second sub question in the sixth mean, it is 10 minus 6x minus 2x square. So take this as f of x and go ahead with the solution. So f of x, which is equals to 10 minus 6x then minus 2x square. Now we will have to go for differentiating both the sides. We get f dash of x, which is equals to derivative of 10 will be 0, leave that, then derivative of minus 6x will be minus 6, and then here we get minus 4x. So now to get the point, we have to equate f dash of x with 0. Now f dash of x equal to 0, then minus 6 minus 4x, which is equals to 0, then this can be written as 4x equal to minus 6, then x is equals to minus 6 by 4 will be minus 3 by 2. So now here the point x equal to minus 3 by 2 divides the number line into two disjoint intervals. So I'll go for the number line. It is minus infinity, then here we have infinity, in between we have minus 3 by 2. So what are the two disjoint intervals now? Minus infinity, open interval minus infinity comma minus 3 by 2, and then minus 3 by 2 comma plus infinity. Let us go for the table. So here it is intervals, and then sine of f dash of x, sine of f dash of x, and then here it is nature of function. Nature of function. So now let us take up the first interval. It is minus infinity comma minus 3 by 2, minus infinity comma minus 3 by 2, minus 3 by 2. Then you have to take a value in between this. Leave the end points, take one value. Minus 3 by 2 is nothing but minus 1.5. So minus 1.5, minus 2, minus 3 and so on. So let us take up minus 3 and substitute in f dash of x. See here, minus 6, minus 4 as it is, in place of x we have to write minus 3. Then minus 6, minus into minus it is plus, 4 into 3 it is 12. Now 12 minus 6 it is 6. That means it has to be greater than 0. 6 is greater than 0. That means sine of f dash of x will be greater than 0. If it is greater than 0, then it is strictly increasing. Strictly increasing. Strictly increasing. Then now you take another point and analyze f dash of x. Here we have taken minus 3. Let us take minus 5 and analyze. So I will write minus 5 here. Then so here we get plus 20, then 20 minus 6 it is 14. So 14 is greater than 0, that is why we have written greater than 0. Then let us go for the second interval. Well, the second interval it is minus 3 by 2 comma infinity. So this is an open interval. You have to leave the end points. Leave minus 3 by 2, that means minus 1.5. After that you get minus 1, 0, plus 1, 2, 3 and so on. So let us take plus 2 here. Substitute in f dash of x. Minus 6, minus 4 into, in place of x I am writing 2. Minus 6 minus 8 will be minus 14, which is less than 0. Or else you take plus 5 and substitute here. You get minus 6 minus 20, it is minus 26, which is less than 0. That means in the open interval minus 3 by 2 comma infinity, f dash of x is going to be less than 0. So here we get less than 0 case. That means it has to be strictly decreasing. Strictly decreasing. So this carries 2 marks. So this is all about the second sub question. Well, the third sub question, it is minus 2x cube minus 9x square minus 12x plus 1. So let us take this as f of x. F of x, which is equals to minus 2x cube, then minus 9x square, then minus 12x plus 1. So now here we go for f dash of x. F dash of x, which is equals to, you get minus 6x square, then minus 18x, and then minus 12. So now take minus 6 common here. So here we can take minus 6 common. F dash of x, which is equals to, so I'll be taking minus 6 outside. What do we get now? Inside the bracket it is x square plus 3x plus 2. Multiply minus 6 with these three terms, you get back the previous term. So now how do you write x square plus 3x plus 2? So f dash of x, which is equals to minus 6 outside, then these two terms can be written as x plus 2 into x plus 1. So x into x, it is x square, x into 1, it is 1x, and here 2x will give us 3x if we add, and then 2 into 1, it is 2. So now to get the point, we have to equate f dash of x with a 0. Now f dash of x equal to 0, then what do we have now? We have minus 6 into x plus 2 into x plus 1, which is equals to 0. Then take minus 6 to the RHS, it will be 0. You get x equal to minus 2 or x equal to minus 1. So this implies the values of x are x equal to minus 2 or x equal to minus 1. So now the points x equal to minus 2 and x equal to minus 1 divides the number line into 3 disjoint intervals. So here in the previous two cases we were getting only 1 point. That is why the intervals were one more than the point. It is 2 intervals. So here we have 2 points. That means we get one more than this. That is 3 disjoint intervals. So let us mark this on the number line. So it is minus infinity, then plus infinity, and then we have here minus 2, and then it is minus 1. So what are the 3 intervals now? Minus infinity comma minus 2, minus 2 comma minus 1, and then minus 1 comma infinity. Let us write the table now. Intervals, and then we have sine of f dash of x, sine of f dash of x, and then we have nature of function, nature of function. So now let us take the intervals now. It is minus infinity comma minus 2, then minus infinity comma minus 2 means you have to leave the end points, take in between values. We can take minus 3, minus 4, minus 5, and so on. Let us take minus 3 and substitute in f dash of x. So f dash of x, which is equals to, I take minus 6 as it is, then minus 3 plus 2, then here minus 3 plus 1. So now f dash of x, which is equals to, you get minus 6, then minus 3 plus 2, it is minus 1, and then minus 3 plus 1, it is minus 2. So see here, minus into minus it is plus, plus into minus it is minus. That means overall the answer will be less than 0. That is why in this interval sine of f dash of x will be less than 0, and hence it is strictly decreasing. Strictly decreasing. Let us go for the second interval now. That is minus 2 comma minus 1. That is minus 2 comma minus 1. Then here let us analyze. Leave the end points. Leave both minus 2 and minus 1. Take in between values. In between we get minus 1.5. Substitute minus 1.5 in f dash of x now. So f dash of x, which is equals to minus 6 outside, then minus 1.5 plus 2, then here we have minus 1.5 plus 1. So overall what do we have? F dash of x which is equals to minus 6 as it is, then 2 minus 1.5 will be 0.5, then 0.5, then here we get minus 0.5, then minus into minus will be plus. Overall it has to be greater than 0. Overall it has to be greater than 0. That means in the open interval minus 2 comma minus 1, f dash of x is going to be greater than 0, and hence it is strictly increasing. So here it is greater than 0, then it is strictly increasing. So now we'll take the last interval, that is minus 1 comma infinity. Minus 1 comma infinity, you have to leave the end points, take in between values. So you can take 0, plus 1, plus 2 and so on. So let me take 0 and analyze. Minus 6, and then 0 plus 2 it is 2, and then 0 plus 1 it is 1. So overall you get minus 12, which is less than 0. So that means in this interval f dash of x is going to be less than 0. It is strictly decreasing. Strictly decreasing. So this is all about the third case. Take the fourth case as an assignment. So I'll be solving the last one. Well, the last case it is x plus 1 the whole cube into x minus 3 the whole cube. So we'll take this as f of x. F of x which is equals to x plus 1 the whole cube, x plus 1 the whole cube into x minus 3 the whole cube. So here we have to differentiate both the sides with respect to x, and here we have product of functions. That means we will have to use u into v the whole dash, which is equals to u dash v plus u v dash. So differentiation of the first function, write the second one as it is, plus now write the first function as it is, differentiate the second function. So here we get f dash of x which is equals to, differentiate the first one, you get 3 times x plus 1 the whole square, and then this is u dash into v, write the second function as it is, x minus 3 the whole cube, plus now write the first function as it is, x plus 1 the whole cube, then differentiate the second one, you get 3 times x minus 3 the whole square. So now in both the terms, what is the common term? It is 3, and then x plus 1 the whole square, and then x minus 3 the whole square. So we'll take the common, f dash of x which is equals to, I'll be taking 3 and x plus 1 the whole square and x minus 3 the whole square common. So we are left out with, see here, these two terms we have already taken out, and then here we are taking out x minus 3 the whole square. That means you have x minus 3 here, and then 3 and x minus 3 the whole square both have been taken outside. Then x plus 1 the whole square means here we will be having x plus 1. Then let us simplify this. F dash of x which is equals to 3 times x plus 1 the whole square into x minus 3 the whole square. Here x plus x will be 2x, and then minus 3 plus 1 it is minus 2. You get 2x minus 2. You get 2x minus 2. Again in these two terms we can take 2 common, and that 2 will be multiplied with 3, we get 6. So f dash of x which is equals to 6 into x plus 1 the whole square into x minus 3 the whole square into, here we get x minus 1. So now to get the point you have to equate f dash of x with 0. So here now f dash of x equal to 0, this implies 6 into x plus 1 the whole square, and then into x minus 3 the whole square into x minus 1 equal to 0. So here what do we get? If we take 6 to the RHS, it will be 0, and then you get x equal to minus 1, x equal to plus 1, and x equal to 3. So this implies x equal to minus 1, x equal to minus 1 comma plus 1 comma plus 3. So these are the values of x. Here we have 3 points, that means one more than this will be the interval. That means overall the points x equal to minus 1, x equal to plus 1, and x equal to plus 3 divides the number line into 4 disjoint intervals. So let me mark those intervals on a number line. So it is minus infinity, and here we have infinity, then it is minus 1, then plus 1, and then plus 3. So we'll go for the table now. It is intervals, sine of f dash of x, and then nature of function. So it is nature of function. So now we'll go for the first interval, minus infinity comma minus 1. So minus infinity comma minus 1 means you have to leave the end points, take in between values. So I can take minus 2, minus 3, and so on. Let us take minus 2 and substitute in f dash of x. So this is our f dash of x, 6, and then here we have to write minus 2. Minus 2 plus 1 will be minus 1, minus 1 the square it is plus 1, then minus 2 minus 3 it is minus 5, minus 5 the square it is plus 25, and then here we have minus 2 minus 1 it is minus 3. So overall you have a minus sign here, that means the product will be less than 0. So sine of f dash of x is going to be less than 0 in this interval. It is strictly decreasing. So let us go for the second interval now. It is minus 1 comma plus 1. So now the next interval it is minus 1 comma plus 1. So leave the end points, take in between values. We can take 0 here, or you can take minus 0.5 or plus 0.5. So I will be taking 0, that will be easier for the simplification. Substitute 0 in this now. So see here, 6 into 0 plus 1 it is 1, 1 the square it is 1, again 0 minus 3 it is minus 3, minus 3 square it is 9, and then here 0 minus 1 it is minus 1. So you have one minus sign, that means the product will be less than 0. So again this is less than 0, it is strictly decreasing. Then let us go for the third interval. It is 1 comma 3. So 1 comma 3. 1 comma 3 means you can take plus 2 or plus 1.5 or plus 2.5. Take 2, that will be easier for the simplification, and substitute in this. So 6, and then 2 plus 1 it is 3, 3 square it is 9, and then 2 minus 3 it is minus 1, minus 1 square it is plus 1, and then 2 minus 1 it is 1. Overall the answer is going to be greater than 0. So it is strictly increasing. And then let us take up the last interval, that is 3 comma infinity. So 3 comma infinity. So I will be taking 3 comma infinity. So here we can take plus 4, plus 5, and so on. So let us take 5, plus 5, and substitute in this. See here, 6 into 5 plus 1 it is 6, 6 square, that is 36. 6 into 36, and here 5 minus 3 it is 2, 2 square will be 4. 6 into 36 into 4, and here 5 minus 1 it is 4. So if you multiply all the numbers, it will be greater than 0. That means it is strictly increasing. strictly increasing. So here overall this can be written as in the intervals minus infinity comma minus 1 union and then minus 1 comma plus 1. In these two intervals the function is strictly decreasing, and then interval 1 comma 3 union open interval 3 comma infinity. In these two intervals it is strictly increasing. So this is all about the last case. With this we have completed the 6th main, and it is very important for 2 marks for the board exam.